Hello, my name is Zach Rowe, and I will be presenting today on the alerting behavior in black-tailed prairie dogs. These behaviors were observed in Broomfield, Colorado. In the distance, you'll be able to hear alerts from another colony. In the top right corner, you'll be able to see a prairie dog pop up, run to the top of the burrow to alert others, and others respond. Prairie dogs are subject to many stimuli, to include predation. In response to these stressors, I hypothesize that cortisol is raised and then in turn, a cascade of hormonal response leading to an initial alarm to the colony or a retreat to the nearest burrow. In a paper exploring the hormone responses of the species, Hernandez et al. 2022 discovered our indicator of perceived predation risk, density of nearby active burrows, did significantly influence hair cortisol concentration, where those with more nearby burrows had lower HCC. This finding supports an increased release of the cortisol hormone in response to environmental stimuli, such as predation. I hypothesize that yearlings are taught how to use the alarming behavior after emerging from their natal burrow. Inexperienced young prairie dogs are not equipped with the knowledge of what predators to alert for. This notion is supported by a paper by Sharon Owings in 2007, which states, following training with experienced adults, juvenile alarm called more frequently, were more vigilant, showed reduced activity, and spent more time in shelters in the presence of all four predators than did juveniles trained without experienced adults. And this finding supports the theory that knowing when to alarm is a learned behavior. Prairie dogs over time have adapted to the threats presented to them. I hypothesize that they have evolved to alert to members of the colony, to maintain consistent protection against predatory threats regardless of the individual's behavior. John Smith et al. In 1976 reported that members of the clan can benefit from this behavior by being able to spend time on activities that require attention. This report supports that constant alertness is shared by the group, which is evolutionarily beneficial. The function of non-kin alerting is an example of indirect fitness benefits. I hypothesize that yearlings with no offspring of their own will risk their own lives to protect its relatives. In a paper by John Hooglin in 1983, he stated that yearling males with non-descendant close genetic relatives in the natal area called significantly more often in response to predators than did yearling males that had immigrated where they lacked close genetic relatives. This statement supports the hypothesis that yearlings will exhibit dangerous behaviors at their own peril for the benefit of their non-descendant kin. In Module 6 of Cogbooks, we discussed benefits of group life. Alarming as a form of communication can also be attributed as predator avoidance. Additionally, the alarm of yearlings can be thought of as cooperative breeding efforts and therefore ties into a reproductive benefit. The causation hypothesis was supported by Hernandez et al. Paper entitled Evaluation of Stress Response in Black-Tailed Prairie Dogs in Arid Regions from the Colonies in Chihuahua, Mexico. The development hypothesis was supported by Cher Owings' paper entitled Effects of Social Learning on Predator Training and Post-Release Survival in Juvenile Black-Tailed Prairie Dogs. The evolution hypothesis was supported by John Smith et al. Paper entitled The Jump-yip Display of Black-Tailed Prairie Dog. The function display was supported by John Hoogland's paper Nepotism and Alarm Calling the Black-Tailed Prairie Dog. Thank you so much for attending my presentation. I hope you learned something.